Alright, today we're looking at AP Stats 2019, question number 2. Researchers are investigating the effectiveness of using a fungus to control the spread of an insect that destroys the trees. The researchers will create 4 different concentrations of fungus mixtures, 0 milliliters per liter, 1.25, 2.5, 3.75. An equal number of the insects will be placed into 20 individual containers. The group of insects in each container will be sprayed with one of 4 mixtures, and the researchers will record the number of insects that are alive in each container 1 week after spraying. Alright. Identify the treatments, experimental units, and response variable of the experiment. Well, the treatments are going to be the 4 different concentrations of fungus mixtures. So it's going to just be the 0 ml per liter, 1.25 ml per liter, 2.5 ml per liter, and 3.75 ml per liter. The experimental units are going to be the 20 individual containers. This is experimental units, this is treatments. Experimental units. The response variable is the, and this is taken straight from the question, number of insects that are still alive in each container 1 week after spraying. Again, the treatment is what you impose upon the experimental units. So you're imposing the different concentrations of fungus mixtures on the 20 individual containers which have an equal number of insects, and the response variable is the number of insects that are still alive 1 week after spraying. Okay, now part B of this question asks for if the experiment has a control group. So you can say this experiment does have a control group. The 0 ml per liter group. These insects will not be affected by fungus because they are receiving 0 milliliters per liter. Therefore, serving as a control for comparison with the other experimental groups. Experimental groups are the ones that had the concentration, and the control group is the one that received the 0 milliliter concentration, but they're all those are the treatments and those experiments. Okay. Part C, determine how the treatments can be randomly assigned to the experimental units so that each treatment has the same number of units. Well, let's see. We're randomly assigning the experimental unit to each treatment. There are 4 treatments and there are 20 individual units. That means we want 5 individual units per treatment. So what you could do this. You could do this. I'll draw it out. 1, 2, 3, 4, 5. I have 20 containers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what you want to do, you want to go to your so do 1, label each container a number 1 to 20. Okay. 2. Go to your calculator, do math, scroll over to probability, go to calc, math, prob, and then choice 8, which is a random rand int no rep. What this basically means is it's a random integer generator that guarantees no repeats. Select it. 3 lower equals 1, upper equals 20, n equals I believe 5, because we want, yeah, 5. And then you keep generating 4. Keep generating sets of 5 until you have 4 unique sets of 5 containers. The first set gets 0 milliliter. Second set gets the 1.25. Gets the 1. Where is it? Gets the 1.25. And so on. All right. Yeah, if you show this diagram and then just say, let's see, this equals container. So you showed how you label each container a number 1 to 20. You mentioned how you're going to go to your calculator. You're basically using a random integer generator with no repeats within the set. You want to generate 4 unique sets of 5. The first set gets the 0 milliliter per liter. Second set gets the next, and the next. All right, so this should be an acceptable response to the second question from the 2019 exam. Thank you.